Okay. Okay, so let's see what is center of mass. It is associated, it is a point associated with system of particles where all the masses of system are supposed to be concentrated. Okay, so we can write the definition. Please note down the definition with me. It is a point associated it is a point associated with, I'm writing in short form, system of particles. SOP is system of particles where all the masses of system are supposed to be concentrated. Okay, so for uniform bodies we can say that center of mass is located at geometric center of the bodies. So for uniform bodies, we can say that center of mass is located at geometric center of the bodies. Okay, what is geometric center? Let's suppose we have a system of two particles like that. This is a body of mass m, and we have another body located at a distance L from first body, and the mass of another body is same as the first body, it is m. Now where is the center of mass will be located? It will be at the geometric center of the bodies, of both the bodies, because they are uniform bodies, both are having the same mass. So center of mass will be situated somewhere in the middle of two bodies having a distance from L by 2 from one body. Okay, L by 2 from here and L by 2 from here. Okay, let's suppose we have a sphere. Suppose we have a sphere. Okay, so now you know that sphere is a uniform body. Mass of a sphere is uniformly located at a distance r from the center. At a distance r from the center, it is located everywhere. So it is a uniform body. So we can assume that center of mass will be located at the geometric center of the body. Geometric center of the body is this point, center of the sphere. So we will assume that center of mass will be located at this point. Okay, so if the mass of the sphere is m, so we can assume that the total mass of the sphere is concentrated at this position. Okay, now let us suppose we have another system of particles situated at the vertices of equilateral triangle. Okay, suppose we have an equilateral triangle and there are three bodies situated at the vertex of this equilateral triangle. Now in this case, center of mass will be located at the centroid of this triangle. Okay, so we can assume that it will be situated somewhere here. It will be situated at centroid. Okay, in case of an equilateral triangle, only in case of an equilateral triangle. or a sphere. Okay, suppose let's take another case. Suppose we have an right angle cylinder, right angle cylinder. And let us suppose the altitude of cylinder is h from the ground. Its height is h from the ground. Okay, now this cylinder is also uniformly distributed. It is a uniform body, so we can say that its center of mass will be situated somewhere at a distance h by 2 from the base. H by 2 from the base. Okay, I think now you are able to understand a little bit our center of mass. Now we will study about types of system of particles. What are the types of system of particles that are we going to study in this chapter? Okay, now first type is discrete object system. Types of system of particles. So every physical system in nature has a system of particles, because every physical system in nature consists of atoms and molecules, and these are particles. So we can assume that every system of every physical system in nature every physical system in nature we can take it as a system of particles. System of particles. Okay, now based on relative location of particles in a system of system of particles can be classified in two categories. Okay, based on their relative location, so we can distribute them in two parts like that. First is discrete object system. Second one is continuous object system. Continuous object system. In discrete system, we are going to study about the systems like this system, the first one that we have studied at the first place, and this equilateral triangle system. They both are the example of discrete object system. Okay, and this is sphere. This is sphere is an example of continuous object system, because every particle is joined with another particle. Okay, they are lined together in the form of to make an extended body. Okay, now these two particles in the first case, they are not making any body. Okay, if we assume that they are joined together but they are not making any type of body. But in the case of a sphere, small particles are consisted together and they are lined together in such a way to form an extended body. Okay, so a sphere is a case of continuous object system, and this first case and third case are the case of discrete object system. We will study in detail about these two systems. Now first one, let us suppose first we will study about discrete object system. Now, system of particles with several independent objects. The definition of this system is system of particles with several independent objects. Okay, we can take type of particles in which, so let's just suppose this is a particle of mass m1 and there is another particle situated at a distance L from first particle and its mass is suppose m2. As you can see, I have made the size of m2 bigger. That means I want to say that m2 is greater than m1. Now we know that m2 is greater than m1, then we can assume that center of mass will be situated somewhere near m2, not near m1, because m2 is heavier. That means the total center of mass of these two system of particles will be situated somewhere near m2. Okay, so it will be situated somewhere between center of mass, location of center of mass will be situated somewhere near greater than L by 2 and smaller than L. Okay, it is the distance from m1. Let us suppose it is situated at a distance x from m1. This is the center of mass and it is situated somewhere here. If it is at distance x from m1, then that means we can say that it will be situated L minus x distance away from m2, because total distance is L. Okay. Now I am taking another case in which we will have three particles like that. Suppose this is our first particle of mass m1 and there is another particle situated its mass is m2. Another particle is also situated, its mass is m3. Now you can see that the size of m3 is greater than m2, the size of m2 is greater than m1. This is a particular meaning of that. That means m2 is greater than m1. That means I can assume that center of mass will be situated somewhere near m2, not in the middle but somewhere near m2. So I can assume this position as center of mass. Suppose here center of mass situated, so center of mass will be m1 plus m2, sum of both the masses, not their average, it will be sum of both the masses. Okay. Now we have two particles only, m1 plus m2 and m3, and let us suppose if m3 is greater than m1 plus m2, that means center of mass will be situated somewhere near m3, isn't it? That means center of mass will be situated somewhere here. Its value is going to be m1 plus m2 plus m3. Okay. So in that way we can say that center of mass will be situated near m3. So in this way we can find out the center of mass of every given system of particles, taking two particles at a single time. Okay, so this particular observation analysis, we can approximately locate the center of mass of a system of any number of isolated particles, but exact location or exact calculation can be done in analytical way only. I will tell you the formula later on, how to find out the exact location of center of mass through the formula. Okay, but in this way we are approximately able to analyze the center of mass, that where it will lie. If a particle is heavier, that means center of mass will lie near to the heavy particle. Okay, now there is another system of particle we have. It is continuous object system. Continuous object system. Now this system of particle is system of particles. When the system of particles are all lined together to form an extended body, they will be known as continuous object system. You can write system of particles all lined together to form an extended body. Okay, suppose examples are sphere. Sphere is an example of continuous object system. Sphere, and you can take an example of cube also. Okay, cube, sphere, or are there any more examples? Cone. Cone is also an example of continuous object system. Now we know that the distribution of cone is not uniform. That means the center of mass will lie where? Where the distribution of particle is more, where the particles are more. So the base of the cone is more heavy. That means if we divide the cone in two parts by its altitude, its base is more heavier than the upper half. Lower half is more heavier than the upper half. That means center of mass will lie, if center of mass is lying at a distance of y, from the base, that means we can say, and its height is h. Let us suppose its altitude is h. That means we can say that y will be smaller than h by 2. Okay. Suppose if we have a disk, now disk is a uniform body. That means center of mass will lie somewhere at the center at a distance r from every particle. Now if I am going to cut this disk in two parts, and I am asking you the center of mass of the half disk, then it will be, suppose it is a half disk, and its center of mass will be somewhere near, suppose it is at a distance y from the base, that means y is going to be less than radius divided by 2. Why is it so? because if I divide this disk in two parts, then you can see the base of the disk is more heavier. Okay, the base of the disk is more heavy. That means center of mass is going to lie in the heavier section. Okay. Okay. Now we will see how to locate the center of mass of a system of particles. Okay. How to locate the center of mass of a system of particles. First, we will study about mass moment. First, we are going to study about mass moment. What is mass moment? Then, with the help of mass moment, we can easily find out the center of mass of any system of particles given to us. Okay, so what is mass moment? For a given point, its mass moment is always calculated with respect to a reference point. That means I am saying that for a given point, let us suppose there is a particle of mass m. I want to find out the mass moment of this particular particle. So I can find out the mass moment with the help of a reference point situated somewhere at a distance r vector from m. Suppose this point is O, from where I am measuring the distance of particle, and it is r vector. Okay, that means I am always going to find out the mass moment with the help of a reference point. Without the help of a reference point, I will not be able to calculate the mass moment of any particle. That means at first I need to choose the reference point. Okay. Now suppose mass moment of m with respect to point was given like this. That means mass moment of m with respect to O, point O, is given by the formula, which is z vector equal to m multiplied by r vector. It is the mass of the particle multiplied by the distance from a reference point. Okay, distance, say distance or position vector. R is the position vector. Position vector. Okay. Now we will talk about center of mass in terms of mass moment. Okay. Next our topic is center of mass in terms of mass moment. So in a system of particle, center of mass is defined as a point about which mass moment of all the particles of system of particle is going to be 0. You can write the definition. In a system of particles, Please pay attention, it is very important. In a system of particles, center of mass is defined as a point about which mass moment of all the particles of system of particle is 0. Okay, or you can say that about which the sum of mass moment of all the particles. Okay, and it is given by with the help of a formula which is summation I equal to 1 to n mi multiplied by ri is equal to 0, where mi is mass of ith particle, particles, not particles, it is particle. Suppose there are n particles, that means we can write n number of particles multiplied by their position vectors, and their sum is going to be 0. Okay, and this ri is position vector of ith particle with respect to center of mass. Write down position vector of ith particle with respect to center of mass. Okay, or we can say that center of mass is a place where you can assume that all the mass of the system to be concentrated. Okay, now we'll see how this is going to be 0. Okay, we are going to develop a formula for two particles, for a system of two particles. So center of mass for a two particle system will be center of mass of a two particle system is going to be, let us suppose we have two particles, one of mass m1 and other of mass m2. Located at a distance L okay. Now center of mass will lie nearer to the heavier particle. So let us suppose if m1 is heavier than m2, that means center of mass will lie somewhere near m1, because m1 is heavier. Okay, let us suppose it is situated at a distance x from the m1, that means from m2 it will be situated at a distance L minus x. Simple. Okay, so by mass moment definition you can write what you can write. By mass moment definition you can write sum of all the mass moments of particle will be 0. So please write by mass moment definition. By mass moment definition of center of mass we use summation I equal to 1 to 2 because there are two particles only, multiply by mi ri vector is equal to 0. I forgot to write the vector, please write down vector here. It is vector mi ri vector. Okay, it is also important, it is also an important formula. Now this will be m2. Yeah, you need to first suppose the direction, which direction will be positive or which direction will be negative, because there here is r vector. Okay, we need to write down the vector. So we can assume that in right direction we have it is a positive direction. Let us suppose this direction is positive x direction and this direction is negative x direction. Okay, so in this way the distance of m2 from center of mass is in positive x direction. That means, what that means? That means m2 multiplied by L minus x I cap plus m1 multiplied by x into minus I cap is going to be 0. The distance of m1 from center of mass is in negative direction. That is why I am writing minus I cap with m1x. Okay, so we can take unit vectors as common and it will be cancelled out, and we can only take the magnitude of both the terms. So it will be m2 L minus x plus, sorry, it will be minus m1 x is equal to 0. Okay, next it will be m2 L is equal to m1 plus m2 x. That means our final formula is going to be x equal to m2 L divided by m1 plus m2. That means x equal to, x is position from m1. So we can develop a short formula, short thing to remember this formula, which is x is the position measured from m1. So it will be mass of other object multiplied by total distance divided by the sum of all the masses. Okay, x is the distance from measured from m1. So we can say x will be equal to mass of other object other than m1 multiplied by total distance between them divided by the total sum of masses. Okay, we will do a question. To understand this in better way. Please note down this formula. So the question is, find the location of center of mass of a system of particles from 2 kg mass. Okay, you know that the mass of another block is 5 kg. That means it is more heavier than the first block, and that also means that center of mass will lie near to 5 kg block. Okay, and we need to find out the center of mass from 2 kg block. That means you can take a distance x from 2 kg block. Okay, you can take center of mass is at distance x from 2 kg block. That means that means from 5 kg block its distance is going to be 10 minus x, because the total distance is 10 meter. They are situated at 10 meter distance apart. Okay, so center of mass, the location of center of mass from 2 kg block will be x equal to, our formula was x was distance from m1 and it is equal to mass of other object multiplied by total distance, and x is from 2 kg block. That means formula, according to the formula, it is mass of other kg block, that is 5 kg multiplied by distance between them divided by total sum of masses, and it is 50 divided by 7 meter. That means center of mass will be situated at a distance 50 by 7 meters from 2 kg block. Okay, and how much mass will be concentrated at there? 7 kgs.
7 kg, sir.
Okay,
Yes, sir. Okay, sir.